vector review. Let's first quickly talk about component vectors. I is one unit in the positive x direction. That just means if you say an I, that's the x value of a vector. So 1, 0 is the technical term for it, or 1, 0, 0 if you're using 3 unit vectors. J is just the y value. So if it's like this, it's 1, 0, 1, sorry. Or in 3 dimensions, 0, 1, 0. And K is the z value. So they don't have that in two dimensions, only 3 dimensions, 0, 0, 1. So all that's just a fancy way of saying this. If you see this is your x value, your y value, your z value. So in vector form, you could write it in this form called component form, or they could write it in vector form, which is x, y, and z. Right? These are equivalent. Likewise, if I give you, I don't know, a vector 3, negative 2, you should be able to write that in component form, which is 3i plus negative 2j, or minus 2j. That's all it is. That's all component form is hey, these are the same thing as these. So the thing you really have to worry about is knowing which one's which. So if I gave you, I don't know, 2j plus 4k, you have to understand that j is a y value. So you don't have an x value here. So it's be 0, 2, 4. Right, that's the thing. I is x, j is y, k is z. That's the important part. Let's talk about vectors in general. Right, so a vector starts at a fixed, which is an arrow, starts at a fixed position. You generally have 2 points that label it. So let's say this is P and Q. The way you name it matters. If I say PQ, I'm saying, hey, you're starting at P and you're going toward Q. If I say QP, I'm saying, hey, you're starting at Q and you're going toward P. Right, so we say this is a tail, as you notice the tail right there, and this is the tip. That's the arrowhead. That's the way you label vectors. You can also label vectors using one letter. That's the general idea, right? So a vector is PQ, so whatever the first letter is, that's where you're starting, and it goes in another direction. The way you add vectors is we're going to add tip to tail. So as you see here, we have this vector A, and we're going to add it to vector B. So what I do is I add the tail to it. I add the top of this arrow, this one, to the end of that one, like kind of connect them. Right, so yeah, kind of adding like that arrow plus that arrow to make like a bigger arrow. And the more important thing though is if you want to get the arrow you just added, all you do is connect those two things. So start here and there. And that's my added arrow. Right, so it's a really quick example. If I give you like this A and this B and say this C, if you want to add them all, you just keep on adding it to the end. So you're like, oh, here's A, B goes up, so add it to the end, C goes that way, so add it to the end. And your answer is going to be start here and here, connect. That'll be all those vectors added together. By the way, let's say this is vector A right here. What is negative A? Well, negative A just goes opposite direction. So if this one's going this way, negative A is going this way. So like if you look up here, notice I have a PQ and QP and they went the opposite direction. That's a general rule. If you have AB and then you switch it to BA, well, BA is going to go in the opposite direction to go from B to A. So it's the same thing as saying negative BA. Right? They're just going the opposite direction, just like here. A and then opposite way, negative A. So another way to write AB is just negative BA. Anyway, why is that important? Well, let's say I wanted to add A minus B. Right? Another way to write A minus B is the same thing as saying A plus negative B. So if I add these up, all I gotta do is add my A. There's my A, try to make a match. And then I need negative B. Remember, negative B is this opposite of regular B. So negative B would be going down. It should be the same length, but I tried. So you just add it to the end here, go down, about the same length. This is A, this is negative B. And then, right, the answer would be connect this end to that end. That is A minus B. So that's how you add and subtract vectors. Let's do a couple quick examples. Look at here, right? Here's P, here's Q. Then I'm going to add P and Q. So I'm just going to go, okay, here's my P about, then add Q to the end of it. Disconnect them, like you're playing Legos or something. And then your answer is going to be the resultant. P plus Q. And again, look at the next one. I'm going to do B, P minus Q. So there again, there's my P. And now I need negative Q. So again, negative Q is the exact same thing. It's going the opposite way. That's negative Q. That's my best guess. And then you connect the endpoints. So this is P minus Q. That's all it is, right? Tip to tail. If they want negative, flip it. Right, this kind of puts it all together right here. They want you to add P, so here's P. Something to this effect. Add it to Q, so Q is going to go straight down. And then they want negative R. I have positive R right now, so negative R is going the opposite direction. So it's going to kind of go from here, so connect that way. And then my answer is that. Where you started to where you ended. P plus Q minus R. So again, that's how you add vectors. On the IB test, they usually don't make you draw it. They want you to add stuff onto an actual graph. So something like this. So here's an example of what the IB test likes to do. In the following diagram, U equals AB. So that's U right here. So we're going to know, okay, U, this is my U, equals AB, and V equals BD. Now again, order matters, so it's going this direction. That's why they put the arrow there. I'm not going to jinx it, but I'm impressed with my line so far. Okay, so they also tell you the midpoint of AD is E. That's important because remember what midpoint means. If that's the midpoint, these are the same. And in vectors, if they're the same, they're like AE. That just says AE equals ED. Because if they're the same, they're equal in vectors. That's the way vectors work. Then they tell you BD is over DC is 1/3. So all they're saying is this. If this is V, right, that's BD is V. Then this side, DC is 3V. Right, because BD is V. That makes DC 3V. So that's the way that works. Just laying it all out there. Now, this is something IB loves to do right here. Express these on the following vectors in terms of U and V. So I can only use these two vectors. That's all they want me to use. I got to get AE out of that. So I got to go from here to there only using those two vectors. Now this is how you do it. Remember, so you got to start at A and you got to end at E. Right, to match this. So I'm starting at A. Now I can only use those two vectors. So if I go this direction, that's vector U. And I'm going to add it. See how this is going proper, like it's going tip to tail, like it connects properly. I could follow this direction. So this vector is like this, and this vector is like that. They do connect. And I get to here. You're like, that's not what I wanted. I wanted AE, not AD. But don't forget, this is the midpoint. So I have AD from here. I only want half of it. So I'm just going to divide this by 2. So AE just equals 1/2 U plus V. It's a little vector notation. Right, because again, this is only half of the whole line. So now I know this line right here is 1/2 this plus that. So now let's erase some of this because I'm going to need it in a second. So I have that. Let me mark this part right here. So I know from A to E, I don't have that vector. That is 1/2 U plus V. Okay, let's get to the second one. They want to go EC. So remember what that means? You want to start at E and go all the way to C. So I'm going to start here. I want to go this way. And then I want to go this way, all the way to C. Well, if you notice, this part's easy. That's 3V. Got that already. What is this part, though? well, remember I said earlier, these are the same. They're midpoints. So this little line here is the same as this line right here. So this is just 1/2 u plus v plus this line, 3v. And there you go, that's your answer. Again, you don't have to make any nicer than that if you don't want to. They care that you understand that concept. If you really want to, you could distribute and get 1/2 u plus 1/2 v plus 3v would get me 1/2 u plus 3 1/2. So that's 3.5 v. But again, this is totally fine. Or 7.5 v, whatever. But that's how you add vectors. That's vector addition in IB. Let's move on. So these are the formulas you see in your formula sheet. Now, very important thing, guys. See how this formula here for magnitude, we'll talk about magnitude a lot in a second. Magnitude is just the length of a vector, how long it is, or size of a vector. You might say it's this big or whatever. That's what magnitude is. Now, if you notice, there's 3 components here. There's v1, v2, v3. If you're doing a 2D vector, remember, vectors come in 2 spots. They could be like this, or they could be like this, right? 2D or 3D. If it's 2D, you just ignore the third one. That's how 2D vectors work. You just ignore the third one. So if I wanted to find the magnitude of this thing, using this notation, I'll just do the square root of the first term squared plus the second term squared. And then you have your magnitude. So again, if you only have 2 things, that's fine. That's the way vectors work. So again, magnitude, that's how long a vector is. This is between 2 points. That's like a geometry thing or basic algebra thing, right? It's just x1 minus x2 squared plus y1 minus y2 squared plus z1. Again, if it's only 2 things, ignore this one. So if you're trying to find how far apart 2 points are, just use this formula. If you're trying to find the midpoint of points, right? How do you find the midpoint? Well, you just take the average. x1 plus x2 divided by 2, y1 plus y2 divided by 2, and so on. Now here are the big ones. Scalar product, also sometimes known as dot product, because the symbol is A dot B. That means dot product. Now here's the formula we actually use. See a little dot right there? Right. So if I want to take a dot product of these two, all I'm going to do is multiply the corresponding parts. I'm going to multiply by v by w, v2 by w2, v3 by w3. It's one of the easiest operations in the world. If I give you this and I say dot this with 3 and 4, I just go, okay, 2 times 3 is 2 times 3 plus 0 times 4. That's a dot product. Right? Easiest thing in the world. Again, if there's three of them, then you multiply the z's also. Now there's some alternate ones here. This one we've never used because these are just all the same thing, but that's just worse. So this is one we're gonna use for dot product. If you want the angle between 2 vectors, it is this. It's kind of a combination of these 2 things. Notice that the dot product on top. That's what this is right here. This is u dot v w. You can just use the formula though, and then divided by the magnitude of each one. So it's the dot product of 2 vectors divided by the magnitude of each vector. And then you do cosine inverse. Vector representation on line, we're going to deal with this a lot, the whole second half of vectors, but in general, you should know that the first thing is the initial point, and B is a direction vector. Again, we'll talk about this way more in a second. One big thing you know about vectors is perpendicular vectors, also known as perpendicular, by the way, if you're not sure, means 90-degree angle. So they could say perpendicular, they could say right angles, they could say 90 degrees. All mean the same thing. If you see one of these, you got to understand that the dot product of those 2 vectors they're talking about equals 0. That's the key. So if 2 things are perpendicular, 2 vectors perpendicular or right or 90, that means the dot product equals 0. Super important because they will ask this on the test. They'll say, hey, these 2 things are perpendicular, or these 2 are 90, or they might allude to the fact that these are 90 or right. That means the dot product equals 0. And we'll do some practice ones in a second. Much less important is parallel vectors. They really don't ask this, it's too easy. Parallel vectors are multiples of each other. So how do you tell a 2 vector parallel? Well, if one you just multiply, if you multiply one by a number to get the other. It's like that's the exact definition. So like these 2 are parallel. Why? If you multiply this vector by -3, right? You multiply both of them, you're going to get negative 6 and 9. So they're parallel. That's all it takes. Right? If I give you 2, negative 3, and you want to multiply by 5, and you get 10 and negative 15, well, now these are parallel. That's all it takes to be parallel. So let's look at a quick example. Consider these 3D vectors, the points P and Q. Find vector PQ. So right, the way we do this, very simple. It is tip minus tail. That's why we find a vector. So in this case, remember the way it works? The tip is Q that has the arrow next to it, minus the tail P. So this is going to be 1, negative 1, 0, minus P, negative 3, 2, 4. You just subtract like terms. 1 minus negative 3 makes it a positive 4. 1 minus 2 makes it a negative 3. 0 minus 4 is a negative 4. So that's my vector PQ. 4, negative 3, negative 4. And in this case, they also label it A. So A and PQ are the same thing. Now find the magnitude of A. Again, that means magnitude. Which is how big is it? How big is A? What's the size of A? Now we have a formula for it. It's in your form sheet right here. You just take the square root of each thing squared. So in this case, since again I just found it, my magnitude would equal 4 squared plus negative 3 squared plus negative 4 squared. Like that. So I should get 16 plus 9 plus 16, which is 32 plus 9 is the square root of 41. So that's the magnitude. That's how long my vector is, square root of 41. By the way, magnitude is also known as speed of a vector, because it's how long, fast it is. So speed also is a magnitude. We'll talk about more of that later too. Couple things. If you do it on your calculator because you're lazy and don't have confidence in your math abilities, don't forget parentheses around the negatives. I get so many students that do this, like negative 3 squared, and then they get negative 9. They're like, what? Yeah. Calculators understand that you mean this. So if you're going to be lazy putting your calculator, make sure you put parentheses around the things you're squaring. So it makes it a positive 9. Calculator doesn't know any better. So that's that one. Look at the next one. The vector B, 2m, negative 7 is perpendicular to A. So again, keyword perpendicular. They could have said lots of things. They could have said form a right angle, make 90 degrees, whatever, right? But when I see those, I got to think, A dot B equals 0. So again, I know what A is. Found it earlier. Got that on check. Now I'm gonna dot it with B, 2m, negative 7, because they said the magic words are perpendicular, so I know they equal 0. Remember the dot product equals? The way you do the product, I'm not sure what I said there. The way you do a dot product, so you multiply across. So 4 times 2 is 8, plus multiply across, negative 3 times n is negative 3m, plus multiply across, 28, equals 0. Now since it's a simple algebra problem, I can add these together. Negative 3m equals 36, plus 36 equals 0. Subtract 36. Divide by negative 3, m equals 12. So m is 12 in that case. Next one. The vector C, negative 6, n, and 6 is parallel to A. So remember again, A is this. So find n. So how are we going to do this? Well, this. Since it's parallel, I know it equals k times something, negative 6 and 6. All you gotta do is solve for one of them. Right? How do I do it? Well, I know if I multiply negative 6 times k, it's going to equal 4. So just divide. K equals negative 4 over 6. So now, for this middle one here, I can do the same thing. Negative 3 equals k times n. But I know what k is now. Plug it in. Negative 3 equals negative 4 over 6 times n. Most of the time you just go, hey, would I multiply this to get this? In this case, it's not so easy. And then here you just multiply by the reciprocal. Negative 6 over 4. Negative 6 over 4. I get 18 or I get like 18 over 4. I get something ugly. Hence why it's not so nice. Negative 9 halves. Most of the time it's something simple. It's like, hey, this is 2m, and I'm telling you it's parallel to like 6, 9. You're like, well, I just multiplied by 3 to get there, so that has to be 3. But in this case, they made it ugly ones because, you know, they hate me. Anyway, next one. Find the angle between A, which again is 4, -3, -4, and D, which is this. So first we need the formula. It's up there. Angle between is this right there. Don't worry about it, I gotta memorize. Cosine of theta equals a dot product. So like they have V1 W1 plus V2 W2 plus V3 W3. Don't worry, don't be impressed, I know this. And then on the bottom is the magnitude. It's very important, magnitudes. So let's do that first, right? Here's A, here's D. It doesn't matter. It should have been V and W. But again, it doesn't matter. So here's A. So first let's find the dot product. So I'm going to multiply the corresponding parts. So 4, -3, -4, dot 2, -1, 2. Again, really should be the easiest math you do. Just multiply across. So 8 plus 3 plus to 4, -8. Hey, these cancel, and I get 3. Now let's do the magnitudes of my two things, right? I need the magnitude of A, which I believe we did earlier, get radical 41. So don't need to do work twice, yay. And then we're going to do the magnitude of D, which is just, right, take each thing, square it, add it together, square root it. 4 plus 1 plus 4, that is 9. Square root of 9 is 3. So one of these is radical 41, and one of these is 3. So I get cosine theta equals 3 over 3 rad 41. I guess I could reduce that if I want, and I get 1 over rad 41. You're like, I'm done. Not really. I want the angle, not cosine of the angle. Unless they want cosine of the angle. They want the angle in this case. So let's cosine inverse this stuff. Put this in our calculator, and we get an answer. One I don't care about right now. Again, notice, keep in mind, let me actually do it, right? If I did cosine inverse, second cosine, 1 over radical 41. I get 1.43. You're like, what is that? Well, that's in radians, so that's fine. You can put that 1.43 in radians, or if you want, go switch to degrees so you have a little more understanding of what's going on. Again, IB takes either. You do that again. 81 degrees. So I have more of an idea of what's going on. Oh, there's 81 degrees in between the two. So about 81 degrees. 81.4, I think. That's the idea. So that's the first part of vectors, right? Just doing all the basic operations. Now let's talk about the second part, which is like the application problems. So lines in space. So like I said before, this is the equation. They'll say find a vector equation of a line. They immediately want you to do this. Now it's all about what each thing means. So A is the initial position. So wherever your vector starts, like if we're doing like the AB thing, A would be, the initial position would be like your vector A, whatever point that is. That's all it is. B is a direction vector, and that's the important thing. B is a direction vector. So, like if I was saying, like, let's make a vector equation of AB, it's not B, it's the direction AB. It's actually this. That's my B there. Which way is it going? So, it's a direction vector. Very important. I'm going to do an example of that later. T is this is everything you plug in. So, T is generally time. So, you'll plug in 2, plug in 3. They call it scalar. Scalar is a fancy word for just a number. So, you plug in 3, 4, you plug some number in there, and it goes to both values, or all 3 values. And R is position, right? So if I say we're at 1,5 at 3 seconds, you plug in 3, and it's going to be 1,5. So R is where you're at. R is the position vector. So let's keep that in mind, right? A is the initial point. It's kind of like a slope equation. You could think about it that way. Like y equals mx plus b. That's essentially what this is, right? Where A is my initial point, like my y. And then B is my slope or my direction vector. And T is time, my x. That's all it is. Very big thing here, super important. If I want to find, if I say, hey, these two vector equations are parallel or perpendicular, find the angle between them, all you care about is the direction vector. That's all we're going to care about. We just care about this guy right here. That guy is the most important part. And we'll do a couple examples, but if I'm talking about, hey, here's these two vector equations. And here's another one. And I said, are these two parallel? Well, then you just look at these two. Again, you only look at the direction vector. Are these two, what's the angle between these two vectors? You just look at the direction vectors. Again, cannot stress enough, super, super important. The direction vector is where it's at. So, okay, let's do an equation real quick. Let's do an example real quick. So here's my vector equation. So just by looking at this, notice the thing that's by itself is my initial position. So it wants to know, hey, what's the initial position? 2, -3. And actually, if we're doing position, it'll be a point, 2, -3. Right, but that's my initial position. What's the velocity vector, also known as the directional vector? Well, that's the one with the variable. That's this one right here. So that's 4, 3. Notice it's a vector, so I'm putting it in the vector form. I could write like that, or I could write it in that component form. 4i plus 3j. I like this one better too. Speed, now that's very important. That is the magnitude of direction. So all you can do, as I said before, right? All we ever care about is the direction vector, is to take the magnitude of that thing. So 4 squared plus 3 squared, right? Using the magnitude formula, I get radical 25, which is 5. So this is going 5. That's how fast it's going. The position after 2 seconds. So what's going on there is they tell you, hey, time is 2 seconds. Where's it at? Well, just plug it in for the t. You're going to get xy equals 2, -3 plus 2 times 4, 3. That 2 goes in both of them. So 2, -3 plus 8 and 6. To sign them up, add up like terms. 2 plus 8 is 10. -3 plus 6 is 3. So that's my position. After 2 seconds, we're at 10.3. We started off at 2, -3, but we're going 5 miles per hour basically, and we end up at 10.3. So again, that's the basics of a vector equation. Let's do a little more difficult one. Alberto is traveling in a glider in the direction 2 to -6 at 6 meters per second. Find the velocity vector of the glider b. So here's the thing. This is a little funky, but this is the direction, but I need to be going 6 miles per hour, basically meters per second. Let's figure out how fast this thing's going. So let's do the speed or the magnitude thing. So let's find the magnitude of our stuff. So 2 squared plus 2 squared plus -1 squared. I get 4 plus 4 plus 1. I get radical 9, which is 3. So I'm only going 3. I need to be going 6. So how do I go from 3 to 6? Times it by 2. So also what we're going to do here, we're going to get our thing and times that thing by 2. So we can get it as fast as we need to get it. So again, a little funky, but that's the idea. If you're saying, hey, we're going this direction, but I want to go this fast, figure out how fast your thing's going, and then it's multiplied by what makes it the speed you want. So in this case, my original thing was only going 3. It wanted 6, so I'm going to multiply that by 2. That'll give me this speed I need. Next part. When t equals 0, Alberto has a position of this. Now, again, t equals 0, that's initial position. That's all this is. This is a fancy way of saying this is initial position, which is A. Hence, write a vector equation in the form of this for the position vector and glider after t seconds. So, we're going to do the equation. Now, you could do r equals minus position 19, -12, and 20 plus t times my vector b, which we just found is 4, 4, -2. There you go. Sometimes IB prefers that we put x, y, z here, so I'll do that instead. But that's the vector equation, right? Just know what your initial position is, and then know what the velocity vector is, or direction vector is. The glider passes through the point D, find the value of P. So it's saying, hey, it actually goes to this point. So what that means is you're going to plug it in for this. So let's do that real quick. So I know my glider is going to go through this point. So I hit it at some point. So you're like, how do I solve this? Well, we're going to see a lot of this. What you do is you split it. Now let's look at this bottom one because I think it's the easiest one. That is 10 equals 20. Remember that t gets multiplied by all of it. Plus -2t. The top one here, Oh, sorry. So that's that one. Why do I have that? Well, if I look at the bottom, I can solve for t really easily. But before we do that, let's look at the middle ones when I need, right? P equals negative 12 plus 4t. So this one I can't solve. I have two variables there. But this bottom one and the top one, if I wanted to also, I could solve. There's only one variable. So let's solve it first. Let's solve that. Minus 20. I get negative 10 equals negative 2t divided by negative 2. T equals 5. So now I know what t is. I can plug it in here. P equals negative 12 plus 4 times 5. P equals negative 12 plus 20. P equals 8. Right? So that's our idea here. If they tell you it's a point that goes through your vector, it's your XYZ part, right? It goes into here. And then the way you solve things, the way you solve a lot of things in vectors, you separate it. Separate all three. You only have to care about the ones you need. So I used the bottom one to find my t. Once I found my t, I was able to plug into the middle one, which had two variables, to find my p. Next part. The position of a balloon after s seconds is given by this. Show the balloon also passes through d. So same idea. We're just going to do the same thing. We're going to set it equal to d. So 39. I know what p is now. Then my new equation. Now all we gotta do here is show that when we separate it, s is the same thing for all of them. So I get 39 equals 19 plus 5s. Now again, shows it passes through d, so I gotta find it. So this solve it minus 19. I get 20 equals 5s. S equals 4. Then you can plug in 4 to all this, and you get 20 negative 4 and 8. If you add it to that, you get what you want. That's all you do. When they say show, literally show. So I would multiply this by 4, get this, do that plus that, and show that I have this. I'm like, okay, I went through it. Now this one, next one. Calculate the Q angle formed between the pass of the balloons when they meet at D. So remember, when I'm looking for an angle between or anything like that, all I care about is the direction vector. I care about this thing, and I care about this thing. That's it. So t is this. We'll say t as label it t because that's what it has. 4, negative 4, and 2, I think. 4, 4, negative 2. And then my other vector, I'll label it s because it's right there. So those are my two vectors. I want the angle between it. I'm going to do a vector equation. Cosine theta is equals VW. Remember, it's not on your formula sheet. Okay, I gotta use this formula though. Over the magnitude of each one. So the answer to that, real quickly. I did a little work off camera, but if you did all that work, you did your stuff, you're gonna get 6.5 here. Anyway, you plug it all in, do inverse cosine like I did here. You're gonna get 68.6. So I'm gonna get theta equals 68.6. Now that is an acute angle, so less than 90, right? That's what Q means. So I'm actually done. But what if they set up obtuse angle between these things? Because they cross like this, and we found this one. If they wanted this one, well, it's actually really easy. Look at it. It's a straight line. Anytime they want an acute or an obtuse angle, like the one that you don't have, when you're doing stuff like this, like you're doing inverse cosine, the way you find this is to do 180 minus that. So if I did 180 minus 68.6, I would get the obtuse angle. So that's how you find an obtuse angle if they give you an acute one, or if you find an acute one, and vice versa. Just subtract it from 180. But again, this one they wanted acute, that's what I got. So let's move on. Here, now it's kind of scratched out, but it says find the intersection of two vector equations. So I want to figure out where this thing and this thing cross. And this is actually a very big problem in IB. They like to ask this question. So when you want to find an intersection of anything, you do the same thing over and over again. You set them equal to each other. That's it. So I'm going to set this vector here plus s times 3, 2, 4 equals to this vector here. So 15, 5, 3 plus t times negative 4, 1, 5. So that's how you, right? That's how you always find stuff when they're intersecting. You set them equal to each other. So now I have this, and like, what do I do next? Well, we do what we always do in vectors. We separate. Hopefully with a better line than mine. Now, if you notice, I only have two variables, so all I need is two equations. Pick any two you want. I'll do the top two just so I don't mess myself up. So I get -2 3 times s equals 15 minus 4t. Now do the middle equation also. 1 plus 2s equals 5 minus plus 4t, I believe. Actually, that's a 1t. So let's erase that. There you go. Now what we do? Well, we have two equations to unknowns here, right? We got to solve elimination substitution. Most people like to put them together, and actually I probably should have done that from the very start. So what was I thinking? So, and then I like to do elimination. So let's get rid of the t's here, right? So, because it's very easy to get rid of them. Multiply the bottom row by 4. I get 4 plus 8s equals 20 plus 4t. If I add those up, the 4's, these will cancel. I get 35 equals 11s plus 2. Subtract 2. 11s equals 33. S equals 3. Now I have s. Now I don't necessarily need to find t. It all depends on the question. The lines intersect at point P, find the coordinates of P. So here's the thing. I don't need to find t. It didn't say find the time at which they intersect. That's what t is. T is the time, s is the time. I know that they intersect at 3 seconds for the first thing, maybe not for the second thing. So I don't need to find s and t unless they specifically ask. What I do need to find is the coordinates of P. And what is that? That is where that's where these things are at their specific value. So what am I trying to say? Not well. Plug this into its vector to find intersection. To find intersection points. That's all I mean. Right, you got your answer. If they're not asking for t, all you have to do, you're not done. You got to plug it back into its vector to find out where they actually crossed, where it was at 3 seconds. So we're gonna do that real quick. So I have -2 1 1 plus 3, because I just found out s is 3. 3 2 4. Let's simplify this. -2 1 1 plus 9 3 12. Which gives me 7 4 13. So that's where the thing hit, or wherever the question was. That's where they intersect at. They intersect at 7 4 13. Like those are coordinates points. The thing you found first is like the time it hit. They intersected at 3 seconds, but where is it at? Plug it back in. Okay, almost done. So a couple quick things here. I might skip some of these. Look, this is a dot product. So just to remind you, the way you do it, you multiply these out. So multiply the matching parts, plus multiply the bottom parts, the matching parts. So -2 plus 12 is 10. Same thing if you have 3 of them, you just multiply across. 8 plus 15 plus -2, add them all up, and I get 21. Right, same thing here. Dot product, you just multiply these two, so I get 12 plus multiply these two, -12, and you get 0. Yes, that's perpendicular, or right, or whatever. So you know these two vectors are perpendicular, right? Because when you dot product, you got a 0. Okay, let's do the last couple of things real quick. This first one should be an easy problem. A lot of people mess up a small part of it. Find a vector equation. See this vector equation. I automatically want to think, look at your formula sheet, r equals a plus tb. Right, so I got to find an initial point, I got to find direction. Now they want me to find the vector equation of a line passing through AB. Right, so I'm doing AB, my initial point should be A. So this part's done. A is just 3 4. Notice I wrote it in vector notation, not point notation. We're talking about vector here. Plus t times b. Now b, I gotta find that. A lot of people just put b there. It is not. That's a second. That's a tip. I need the direction. And direction is like how you find AB. Tip minus tail. So that's my direction. Just like how you find this vector here, same idea. Tip minus tail. So 1 7 minus 3 4. I get -2 and 3. That's what this vector is. Set it equal to r, I guess. And we're done with that one. The last one, I'm not going to solve all the way, but I do want to talk about it. So given points A, B, C, find the measure of angle ABC. So first thing, when they say measure of an angle and there's only 3 letters, you're talking about the middle one. We want to find the measure of angle B. Next, you have points A, B, C. Now, I like to plot them, not exactly because I don't really care, but like, I want to get a bearing of what's going on. So A, B, and C. Again, I know they don't really match with the points, so I just don't care right now. Right, so here are my 3 points. Again, notice I want angle B, so I want the angle to be at B. So it means I have to have a vector going this way, called BA, and a vector going this way, called BC, right? Because that's what it's asking about. So if you want to find the measure of the angle, remember we have a formula for that. That is, we used it recently. Cosine theta equals u dot v over magnitude of u and magnitude of v. So first, let's about the u dot v. That is this right here, right? That's one of them. That's like my u. My u is BA. My v is this one right here, BC. Well, what is BA? Remember the way we do that? We do A minus B. So 35, tip minus tail, minus negative 1, 4. And I get 4 over 1. So that'll be the vector here. 4 over 1, 4 squared plus 1 squared. And now, I need to find BC the same way. That is C minus B, tip minus tail. So that is 2, negative 2, minus negative 1, 4. And I get 3 and negative 6. So that would go here, 3, negative 6, which I could expand here and actually find it. Right? Put that into your calculator, get some decimal, and then do cosine inverse of both sides, and you get your answer. Right? But that's the general idea. If you get something like this, you could build your own vector. Just lay out the points, right? And just see where they want you to go. Oh, they want me to find B, so B is my angle, because remember, that's how you find our angle. And then set up the values. So that's it.